Hi everyone, my name is Zhenxing Li, and I'm gonna deliver a presentation for engineering research method. My topic is optimization of multi-agent system on both solar and wind energy using Internet of Things technique. And this presentation will be divided into 4 parts. Part 1 is introduction. I'm gonna introduce some basic information of multi-agent microgrid. And the second one, literature review. I will review some of the previous research and conclude their limitation, and then point to my research question. The third part is research design. I will deliver a very detailed description of my design. And the last one is conclusion of the whole research. So my research question is to optimize the performance of microgrid with a very comprehensive consideration of energy, meaning wind and solar energy, and also test them with real hardware. So as we know nowadays, renewable energy has become much more popular, such as solar energy, wind energy, tidal energy, and so on. These renewable energy are all green energy, which means they are very friendly to the environment, to the ecosystem. And one more thing to mention, they are very economic because you can trade this energy to make profits. So how can we store and utilize this renewable energy? In this issue, a microgrid plays a very important role. So a microgrid is a small-scale control and management network for this power generation and distribution. Typically, the microgrid consists of one or more than one different distributed energy. I mean, like solar energy, wind energy, tidal energy, many things. And also, an energy management system, also called EMS, is included in microgrid. So what's an EMS? EMS is used to implement the operation of this energy generation and transmission. So with this EMS, we can use the microgrid to achieve the low demand, like charge your electrical vehicle, to make energy for your battery and something. One more thing is we can store this energy as backup energy for future use. And one more thing is we can trade this energy to the main grid for profits. We can make money to trading them. So due to all the description just now, we can see the significance of a much more smarter EMS has become very important. Therefore, people also use multi-agent system to connect it with ENS. So what's multi-agent system? In this system, we have many agents, like multi-agents, and each agent represents one microgrid. So this microgrid, they need to communicate with each other, but how? They use agent. Agent represent them to communicate with each other for the data, to how to train this renewable energy, to how to store them, and something like that. Typically, a great many previous research, they use a centralized framework-based multi-agent system. A centralized is they have centralized agents in the center, and if the other agents want to communicate with the other one, they need to have the information through the central agents. However, this framework has become much more outdated because they have bad fault tolerance here, and they have very low efficiency. And now I will review some previous research on how they implement this microgrid. So in research 1, a peer-to-peer solar microgrid and also combined with an IoT platform, ThinkSpeed, is presented, and their achievement is this demonstrates some very effective and economic access to research on new EMS algorithm, but concerning on solar energy. And in research 2, a solar microgrid model called ENGG851-Zhenxing has been implemented and proposed, and they can keep the dynamics and stability of the microgrid. And also, as we mentioned in chapter 1 introduction, a centralized framework microgrid has become outdated, so many research have worked on decentralized microgrid. And in research 3, they propose a decentralized multi-agent ENS architecture They also use the non-cooperative game theory. And their achievement is that they compare with many previous research, and the results suggest that their performance is much better. And in research 4, they implement a hierarchy decentralized multi-agent EMS with fault-tolerant feature, and they effectively improve the performance of energy dispatch. However, all of the research just now, they have the common limitation. For one thing, they only focus on solar energy, but they ignore the wind energy. However, we have investigation suggesting that nowadays solar and wind energy respectively account for 50% and 40% of the total renewable energy production. And the second limitation is all of this method and algorithm have not been tested with a real hardware devices. And this also points to my research question. I'm going to achieve a better optimization performance with a comprehensive consideration of the like both solar and wind energy. And one more thing, I would test them with real hardware. So my research proposed a decentralized multi-agent EMS for both solar and wind microgrid. It's also based on Internet of Things platform named ThinkSpeak. Now I'm going to introduce the design process very detailed. So what's the Internet of Things? Internet of Things is also named IoT, refers to connecting everything to the internet together. It's like the people information, the devices, data, and the data from the microgrid or from the sensor. And IoT is also a very promising future network technique. It can also enable the improvement and evolution of microgrid towards a much intelligent grid named smart grid. So this ThinkSpeak platform, we're going to use them to aggregate data from various devices like sensor and microgrid, and we're going to visualize and evaluate this data very comprehensively. So this is like a structure of my whole design. So we have ThinkSpeak as the data controlling, it's over everything, and inside the ThinkSpeak platform we have the microgrid, and here is 5 agents as example, and they have a decentralized framework because they don't have a centralized agent to represent their communication. And here, as we see, all of the microgrid is connected with sensor. So this sensor can communicate with the agent, and then they communicate through ThinkSpeak to achieve a better performance. So conclusion. This research has proposed a decentralized multi-agent EMS for both solar and wind microgrid, and it's based on IoT platform ThinkSpeak. And its advantages can be, for one thing, it has a comprehensive consideration of this DER. I mean, both solar and wind energies are considered. And the second one is we have test this proposed model through real hardware, the IoT platform, and sensor. And the third is we can visualize and control this numerous data in a very efficient way through ThinkSpeak. And we can, in this way, we can strike a balance between the energy production and consumption. And one more thing we have achieved to optimize the multi-agent system through a decentralized framework. But this research also has some of the limitation. One thing is it has a very complicated model because we need to build on real hardware, a lot of devices. Okay, so second one is the adaptability of this model remains to be discovered because in wind or solar energy we have many uncertainties. And the last one is the cost of the whole system may be much more higher than the previous research. And so the future research will focus on how to solve this problem, these disadvantages. And that's all of my presentation. Thank you for watching.